Back. Today we are going to learn about NoSQL databases. So to understand NoSQL, we'll first understand what is schema, what SQL databases are, and then how NoSQL is different. That is what we are going to learn today. So what is schema? So a schema is like a blueprint for the database. Okay, it tells the computer what fields or columns exist in the database, what type of data each column stores, let us say int, text, date, etc, etc. So and what rules apply, like not null, primary key. So before even we start storing data, the database structure must already be designed. Okay, so simply I can say schema is nothing but it is equal to fixed structure. Schema is nothing but fixed structure. Already that everything is fixed. The thing is the information may vary. Okay, so let us discuss one example here. Think about a college admission form. So before students fill the form, the format is already decided. The form that is given to you already is fixed. That is we call it as schema. So if schema is fixed, you can't change. For example, if for example there is a details like name, age, phone number, but management is forgot to add the email address. They can't add it only to Ilyas, only to Hemant, only to Shankar. They need to change the whole form because schema is fixed for every form. Okay, so if they want to change again, the schema should be changed. Okay, but whereas in SQL the schema is fixed, so everyone fills the same kind of form, right, with the same fields like name, age, course. That's how exactly schema works. Okay, the format is already decided. If they want to change for adding email, they need to change whole form. Okay, it is not like for a student constant, they need to change for all. Now SQL database. So in SQL database, data is stored in tables just like Excel sheets. Okay, so a table has rows and columns. Every row follows the same structure defined by the schema. It is not like individuality. If one schema is fixed, everyone need to follow that. Okay, if HOD says something, every faculty should follow that. Means the schema is fixed by the management. Okay, so if you look into the example that I have provided here, if you look here, here is an SQL example. So we create a table called student. Okay, we are creating a table called student. So in that we are creating student ID, name, age, course. So these are nothing but schema. So schema table is fixed. These are the things I want. The schema is fixed. But what may vary? Name, ID, age, course may vary because every student has different, right? Different names, different IDs, different age, different course, right? So before inserting data, the structure is already fixed. Okay. Now if you look here, this is how the table will look once data is inserted. Each row follows the same column structure. So if you look here, student ID, name, age, course is fixed, but inside the table the values are varying. Okay, so some important points are there in SQL schema. So the schema is already fixed. That is what you need to remember. So you must define columns first. Okay, every row must watch or match the same structure. Okay, for example, if you suddenly want to add something new like email address, hobbies, profile photo, you cannot simply add it for one student. It is not for Sanya, it is not for Lavanya. You must change the entire table using commands like alter table. So conclusion is nothing but SQL is not flexible when structure changing frequently. Okay, nowadays social media producing the continuous data, so SQL will not give any flexibility for such type of conditions. So that is why we require NoSQL. That I will discuss later. So problems with SQL. So you already you get some idea, right? SQL databases become difficult when data keeps continuously changing. Data includes images or videos, okay, logs, okay. There is huge and fast growing data. That is why SQL, NoSQL databases were created to solve the limitations of SQL. These are the limitations. So, NoSQL stands for not only structured query language, okay. So this means we are not limited to tables anymore, okay. NoSQL databases allow different ways to store data, not just rows and columns, okay. That is what NoSQL gives us. If you look into the diagram, we start with NoSQL database. So this is our real database full of JSON documents. It contains full of JSON documents, okay. So a script scans all documents and extract structure patterns, okay, in MapReduce. So finds all fields, for example, find all fields, types, nexting, etc., etc. So you will be getting the output is nothing but raw schema collection. Think of this like a messy draft schema info, okay. Now what is the third step? Schema to architect type transformation. This step cleans and organizes the raw schema into standard archetypes, okay. So that archetype that are nothing but reusable schema building blocks, okay. So the output will be versioned archetype collections, raw to versioned archetype collections. So this allow version tracking, consistency and reuse, okay. And then we'll be following reverse engineering process using these archetypes. So the system construct a formal NoSQL schema model like a clean diagram or definition of structure, okay. So we'll be following the formal NoSQL schema model. So then schema NoSQL schema meta model. If you look here, so this is the meta definition, the rules that any schema model must follow. So schema model conforms to schema meta model, that model is equal to specific schema, meta model is equal to grammar or structure for schemas. Model is nothing but specific schema. Meta model is nothing but has some grammar or structure of for schemas, okay. Then we'll be going for tool generation. So from the schema model, tools can be created automatically like schema viewer, that is nothing but visualizing for your data structure, and data validator, like check if data matches the schema or not, and migration assistant help update or update old data. So you move from messy real world NoSQL data to clean schema to useful tools, okay. So this shows how NoSQL stores related data together in JSON documents, unlike SQL which splits data into many tables, okay. So this is how the process to discover a schema from NoSQL database and use it automatically to create some useful tools like validators or migration helpers, okay. This is about the diagram. Now if you look here, so traditional SQL databases work great for small to medium structured data, but struggle when data becomes very large, data changes frequently, and millions of users access it at once. So performance goes down when down because SQL must follow strict schema. Okay, it must follow strict schema. If this happens, SQL will fail. So modern applications like if you look here, model applications generate huge amounts of data like photos, okay, PDFs, videos, charts, sensor data, logs. SQL was not originally designed for this kind of data. So NoSQL become necessary in recent times. Now I have given some important terminologies that we are going through these particular slides. So JSON, if you look here, NoSQL database that does not rely on tables. That is what about NoSQL. JSON, a lightweight text format used to store and transfer data. XML is nothing but a tag based structured format. So DBMS you already know, you're already aware of that. Software that manages database. You will see JSON very often in NoSQL. Okay, JSON will be the thing, the main component of NoSQL. Now we'll be discussing about JSON. So JSON stands for JavaScript Object Notation. So JavaScript Object Notation. It stores data in key value pairs. Like if you say name Ravi. So key is nothing but name. Ravi is nothing but value. Okay. So I given one example here. If you look here, student ID key, name is also key, age is also key, course is also key, skills are also key. These are nothing but values. Rest are nothing but values. Values may differ for every student. Okay, it is not fixed, but keys are fixed. Keys are initially fixed in JSON file. Okay. So JSON is lightweight. What are the advantages of JSON? Is nothing but JSON is lightweight, fast and easy to read. Okay. So it is popular in like websites, mobile apps, APIs and NoSQL databases like MongoDB. So this is very popular. Now moving on to extensible markup language, that is nothing but we call it as XML. So XML is another data format. Unlike JSON, it uses tags. Okay. For example, if you see name Ravi slash name. So it uses tags. This we call it as tags. Okay, to store the data. It is more it is more verbose than and commonly used in like government systems. Okay, bankings, configuration files and old legacy systems. If you see here, this is how tags will be stored. Student ID, these are tag, name tag, age tag, course tag and student whole file will be a tag. So XML stores in this form. So this way, these are some use cases of XML. So we'll be moving next for the important step, types of NoSQL databases. So NoSQL databases mainly fall into four categories. So key value databases, document databases, column family databases and graph databases. We'll understand each one with examples. Okay. Now let us discuss about key value databases. So the here data is stored as key value. So key is a like a unique ID, but whereas the value is the actual data stored. So the important thing is the database does not care about the value contains. It simply stores it and retrieves it very fast. Okay, that is what you need to remember. So already I given, think of keys like a roll number. Okay, think of keys as a roll number and the value is completely or is the value as the complete student information. So when we give the roll number, the database immediately returns the student's entire record. Okay, if I click the roll number, okay, I will get the data of Ilyas completely. Okay, that is how the key and value differs. That is what you remember. Okay, if you look here, I given one example here. So for example, let us say key is 133, that is nothing but roll number, let us say, and the value is Chandana and female. So the gender will be displayed. If I click key in the database, I will be getting all this value. Okay, if I click 134, I will be getting all this value. If I click 135, I will be getting all this value. Dharma Reddy is from male gender. Okay, so each key stores one piece of information and the key must be unique. You please remember, key must be unique. The value will be changing, but key will not change. That is what the thing you need to remember. That is where you need to be cautious. Okay, now key in object form. If you look here, we can also store the value as object. Like if you see here 130, so this comes under object. Okay, so the value can store any data structure. Okay, that is what about key value databases. So I will be discussing some characteristics of key value databases. So these are very important points. So there is no schema. That is what you need to remember. No fixed columns as SQL. We cannot search inside the value easily. That is what the drawback. Okay. But it is extremely fast. It is very simple to use. Okay. That is why companies use it when speed matters. Okay. When they want something in fast manner, they will be using key value databases. Okay. Some real wise use cases with students are given. So key value databases uh, are useful for temporary and fast data like login session storage, catching student profiles after login, temporary exam access tokens. So when a sudden logs in, the data loads instantly. That is what we'll be using key value databases. So examples for key value databases. So some real world key value databases are Redis, Amazon, DynamoDB. So these are used by big tech companies for speed critical systems. Okay. Now we'll be seeing. Have given the diagram here for NoSQL. Already discussed, but please go through the diagram. Column family, key value, document model, and graph model. These are the four types. Okay, I won't spend more time here. So now we'll be going on to the second type, that is nothing but document, document, no SQL database. So this slide shows how table of students converted into JSON documents. If you look here, this is the table and this is converted to JSON document. If I click student Jill, and I will be getting all those details. Okay. So each document contains complete information but one record like student. So instead of rows and columns, we use documents. Okay. So now what is document model or document database? A document database is nothing but NoSQL database stores data in forms of documents, not in forms of tables. Each document contains complete information. One document is nothing but complete information. If I click, for example, if I say some roll number, if I click that roll number, I need to get the records of his complete 3 years. How, what is the CGPA of first year, what is the CGPA of second year, what is his attendance percentage. So instead of rows and columns, we use documents. Okay, that is nothing but document database. So how document databases are stored? So document databases usually store data in JSON format. I think I already discussed about JSON format. There is no fixed schema. That is what you need to remember. There is no fixed schema as in SQL database. So different documents can have different fields. Okay. JSON is readable, matches web and app data. Okay. So I have created some JSON files for student documents. So if you look here, student roll number, name and gender. If I click something about like roll number, then I will get all those data. Okay. So each student is stored in one document, one JSON document. Some students have hostel info, internship info, or email. If you look in next example, so another example, if you look here, then the same thing. I have stored everything, but the information is varying. Here I have stored the email address also. If you look into another example, I have stored hostel, whether Dharma is living in the hostel or not. Okay. So if you look here, whether Sheikh Abdul is going for internship in A or not. Okay. So if you look here, and that is okay because there is no fixed structure. That is why I have stored every JSON file with different variables, different schemas. Okay, there is no fixed structure like in SQL. I have stored everything differently. 4 databases, 4 different columns, 4 different rows I have used. Okay. So one real life example I have imported here. Imagine a folder named students. Okay, each student has their own file. So inside it, each student has their own file. Some files have extra details, some files have fewer details. Okay, each file is independent. Okay, It is not like each file should only have these details, this file document 1 should have this detail, document 2 this should have this, not fixed. It is completely different and completely independent. Okay, now where these data documents will be used? So document databases are commonly used in college portals, okay, admission systems, student profiles. Anywhere data may vary from person to person. Okay, that is why we'll be using these databases. Now, why document databases are useful? So these databases are powerful because all data of one student is stored in one place. Okay, adding new details only affects one document, not entire document. So no need to change the whole database structure. That is what the main advantage. Now, one example I have given examples for document models, MongoDB and CouchDB. So MongoDB is one of the most powerful NoSQL databases in the world right now. Okay. So now we are moving on to the third type, that is nothing but column based family. Okay. So a column family databases store data in group of related columns instead of rows. Okay, it stores group of columns, related columns instead of rows. Okay, data is stored category wise, like CSC one category, CAI one category, ECE one category, in the same, not stored as complete rows. That is what about column families. So columns are grouped into families such as personal info, academic info. They are linked using a raw key like roll number. If roll based on roll number, this personal info and academic info will be linked. Now, if you look here, for each student, raw key identifies, okay, row key identifies, not row key identifies the student. So personal details go into one column family, and academic details go into another column families. Different students can behave different number of columns. Okay, they can have different number of columns. If you look here, Samina, so the personal info and academic info. So personal info goes to one column, and whereas academic info goes to one column. And if you look here, again personal info, academic info of Bhargav. If you look here, personal info, and if I enter this row key, I'll be getting all those details. Okay. If you look here, for Arshida also same thing. Okay. So different students can have different number of columns. Okay, that is what you need to remember. It is not like fixed. Imagine a vertical notebook, okay, for each student. So you add new information whenever you need it. Okay, there is no empty pages for unused data. That is what about columnar family. So why columnar family is powerful? So these databases are fast for large scale data, so great for analytics, and flexible and scalable. So they are ideal for big data. That is why we will be using columnar databases. So some real life use cases I have provided here. They are used in attendance systems, or performance analytics of a student, large university databases which contains millions of students in their college institutes. Okay, so I given examples here. So Apache Cassandra and Apache HBase will be the use examples for columnar family. And the last thing is nothing but graph NoSQL databases. So what is graph database? A graph database stores in the form of nodes and relationships. So for example, A to B. So A and B are nothing but nodes. This nothing but relationship, how they are connected. So that is how NoSQL graph NoSQL database stores the data. So for example, a student is node, a course is another node, enrolled in is nothing but the relationship between them. Okay, now students can be connected as friends, classmates. Okay, project partners, course enrollments. If you look here, I have took four names. So they may be connected in form of friends, classmates, project partners, course enrollments. Okay, if you look here, Sheikh Riaz is a friend of Sami, and Sai Rupa is a classmate of Hemanta. Vaishnavi is the project partner of for Likita. Okay, so they're having different connections. Okay, student can they may be friends, classmates, project partners, course enrollments. Okay, so for example, Sheikh Riaz enrolled in BTech, Vaishnavi enrolled in BTech. Okay, so why graph databases are powerful? So they are very fast for finding relationships without complex SQL joins. Okay, they are very fast for finding relationships between the students. So perfect for connected data. That is what the graph databases advantages. Some real life real use cases have been provided here, so which are used in social network analysis or student social networks. So which student is connected to which student, and even alumni networks for getting placements, or whether the senior is got placed in the so and so, you need to get some connections, right? So graph based database help in those such type of conditions. And last one is nothing but recommendation systems. Okay, and example for graph based database, a popular graph database is nothing but neo4j, so which used by many large companies. Okay, that is what about NoSQL databases. If you are having any doubt, let me know in the comment section. Thank you guys.